What's up, gamers? So this bit I wanted to do for a while where I program, but I pretend it's literally 1984, like it's literally 1984. So, like I don't have the internet, but I want, yeah, and I'm gonna try programming in fourth. I know some fourth, but not that well. But that's okay because I have the book, the physical book that explains things on my other screen. Not other screen. I have the physical book, right? Yeah, on my desk, and I have my pen and paper. That I actually do have. And there's this paper that came out uh, 2 years ago in this the magazine that I'm subscribed to, and so I read in an encyclopedia online. Physical encyclopedia. Yeah, physical wiki encyclopedia thing. That this paper describes the LZSS compression algorithm, which is described a little bit in the encyclopedia, but not that much. LZ is for two people who I think are mentioned in this paper, and SS is these two people. And so it turns out that, from my understanding, it doesn't seem that bad to try and implement. And so I'm gonna try implementing it in fourth. It's been like low key 6 months since I programmed in fourth, and yeah, this is mostly just motivation to like actually sit down and program for an hour because I have not been programming outside of work. I've kind of like skimmed the paper, so like the first like 15 pages are kind of just math, it seems like, and it's really only the last part that really describes the algorithm. But I should probably understand the math anyway, so I'm gonna just kind of go through it and see. Yeah, so I guess the complexity of encoding and decoding schemes is kind of the part that actually has compression. Yeah, hopefully my attention span lasts like an hour and a half at 9:30. Okay, wait. Discussion section 5 examines. Okay, so they introduced them, I guess, earlier on, and then yeah. Okay, shout out the complexity theorists. My attention span's already dying. Oh my god. Okay. Maybe if I talk as I'm reading, like I can. Jesus Christ. So this is the length. So the minimum of two strings is just the shorter one. This is. Oh, if S is okay. So it's the size of the multiset. Like, not taking unique ones. The We're defining the ceiling function notation. Was this not standard in 1980? It's 1984. I guess it's not. It's not standard. Yeah. And even, to be honest, like most of the string notation is kind of agreed upon nowadays. In 1984, it's been 2 years. Okay, the way a pointer is written is not important. Well, a good thing that my fourth implementation has strings, which are exactly a pointer to an address and a length. Okay, yeah. Wait, what? Okay, yeah, so this is literally how pointers work and forth. That's kind of fun. Under the external macro. Wait, where did we? A source string is encoded as a pair of strings, a dictionary, and a skeleton. Okay, wait, stop skipping paragraphs. Okay, so, yeah, so, okay, and then internal is you replace, okay, so from what I read in the encyclopedia, this seemed like an internal one. You would just replace, like, any string with a pair of numbers which represent a thing further back. But I guess maybe there's just, like, multiple different algorithms in here. Okay. Yeah, I guess this is slightly different from, I mean, because I want my pointers to be 1 byte, I think. Or maybe, yeah, 2 bytes or something. Ooh, how am I? Okay, yeah, that's slightly unfortunate. Okay, because, yeah, I want, like, a 2 byte pointer is, honestly, like, 1 byte pointer. So I know this is like a sliding window thing, and so if I have a 1 byte pointer, like, I can go up to, like, 256 characters back, so that can just be my sliding window. It, I didn't say anything about implementing a good version of this compression algorithm. So then I guess I can just have characters as pointers. So I would just, yeah. Just to make sure to use a bunch of character things everywhere for those. So pointer would be a character and a length, or I mean, I guess it would be 2 characters. Like the kind of pointer I want to use, because I don't want to, I mean, the pointers in fourth are, you know, I have a 64-bit system in 1984. It's pretty impressive. Um, yeah, so I don't think replacing, a 5 byte substring with an 8 byte pointer is gonna reduce the size of my, yeah, the thing. Okay, I'm not reading the references. This was already the references. How am I gonna depth first search this? Yeah, so externally you would just have, okay, so this is the dictionary. But then this way, oh my god, typesetting before LaTeX is, I mean, we don't have LaTeX, it's 1984. Yeah, typesetting just kind of sucks right now. So this is 1416 and 1516. So this is better. This is 14. I mean 4. I guess 5, 6, 7, 8, 9. What? How is this 14? Or I guess is the pair supposed to be the size of the pointer is supposed to be 1? So 4. I think we need the separated character 5, 6, 7, 8, 9, 10, 11, 14, 15. Okay, no. So I guess we also don't count the separated character. But like this feels kind of like cheating. I don't know. Maybe I mean I guess then you're not doing any compression at all because if this really counts as 2 characters, then I mean you've replaced 2 characters with 2 characters. So oh, and also I mean don't you need to be able to tell that your character's a. Okay, this looks complicated. Yeah, it makes sense. Like for decoding, this seems like it would be kind of a nightmare. Because I have to know when I'm looking at a pointer as opposed to a normal character in the string. Uh, yeah. Right. Okay. Because like the thing I technically like shouldn't. I mean, okay, so maybe like for now. How Okay, maybe it's just later in here. Maybe I shouldn't be thinking about this yet. Like, basically, I mean, I guess if there's only 127, I could just, use 128 because I have a whole byte anyway. What is the flag for? My ASCII knowledge is lacking, I guess. That's because they haven't standardized it that well. This is 1984. Um, because yeah, if I so if I just use character 128, then it's fine. Because then, so if I see character 128, then I know the next 2 bytes are actually supposed to be parsed as a pointer. And so that means that as long as I'm replacing a string of length 3 or longer, so if there's ever a repeated thing of more than 3 characters, then I can save on space by just pointing back to the original. Okay, wait, what? Okay. So I think I'll also just stick to left pointers. Oh yeah, this is the LNZ and LCSS. So recursion, but not cycles. Okay, yeah, this is more complicated than I think I need to be. Okay, so 4 basic macro schemes. Uh, so external pointer macro scheme, compressed pointer. Okay, so I think I'm doing OPM, right? Because I didn't. I mean, the dictionary thing shouldn't be that bad. Maybe the dictionary is even simpler. Yeah, maybe it is. I mean, it does come first. A good old structure of the paper theorem. The earlier part is more understandable. Up there with the nice answer theorem. If you get the answer on a math test and it's like some disgusting radical or something, you probably did it wrong. But if you get like 7, that's got to be right. Yeah, okay, so maybe I'll just do this. So S0, a separator character, one character, the asymptote, yeah, asymptotically works. It doesn't matter. It's not real. Depends. Ooh, so you could like have the pointers on a heap, I guess. I I feel like is topologically the way we would say like as a tree or something now in the present in 1984, right? I mean, I don't. Wait, what? Where does this? There's. Okay, yeah, yeah. Minimal length. I will definitely not be. Oh, they assume that the length of hashtag equals 0. Okay. Reading the paper explains the paper. Okay, in my defense, they put this reference like a page after they said that that was 14 out of 16. Okay. So I'm doing no recursion because I will just point to the dictionary. Oh, S0 and S1 consist of. Yeah, so I may start out just to get something implementing the simplest form. That's not what he wanted to cook. Yeah, okay, so yeah. I mean this is it's a combinatorial explosion. There are a lot of possible compression algorithms. I guess infinite contact glitch, implement all of these. Every permutation. Okay, yeah, so the external macro model. Treat all pointers as compressed pointers. Okay, what? Interesting. So we don't care? Right? Okay, let me just write down those things as well. Yeah, I need to write down words that they made up. Oh wait, okay, I guess that's obvious, right? Because if the dictionary is part of the compressed string only, then every pointer only, yeah, yeah. Okay, wait, I'm being silly. Okay, yeah. Okay, so this is the move. Section 3. Oh, ah. Authors in the past have used the EPM scheme and not the OEPM. Okay, I'm writing these down too. Yeah, okay, I'm just writing these down. Okay, so EPM, you have S0, hashtag S1. So C is in S0, it's in sigma. Or it's a pointer to S0. So okay. Also, I'm cooking up the most diabolical notation. Like, okay. This is whatever. I will probably understand it if I read it tomorrow. Okay. So CPM is T. Okay, I should. Okay. T bracket I. So characters of T are either sigma or T pointers. And then. Okay, so you form the string. Okay. I guess, yeah, I mean, that's. You maybe don't have to build the whole string, though, right? You can kind of do this stream-wise. So if you restrict S0 to only be strings and not have any pointers, then this is one pass. It's kind of, I'm basically, I've typed 0 characters. I mean, it makes sense, typing's kind of difficult with my, did they have good keyboards in 1984? I mean, do we have good keyboards in 1984? I guess there was that Apple ad, right? That was famous. Yeah. We had. Oh yeah, I'm using my Apple. What, Apple II? Yeah. So by the sequence of pointers. Okay. This, I don't really understand that. Why? Like, yeah. Like, I guess, I mean, wouldn't you just encode this? Like, you need to store what these were pointing to anyway, right? So, isn't this just this? I guess this is, yeah, this makes more sense than this, and this depends on this. So what? Like, yeah, I mean, I just, okay. Yeah, so I think for me, I'm just gonna have a dictionary at the front and then just replace repeated substrings of length. Or, I mean, also just every substring of length greater than 3 with that pointer. And so if there are even, oh, I guess you kind of waste space unless, ooh, because then you have the dictionary and the pointer, so that's actually double. So it actually wastes space unless there's a second occurrence. Okay. But that seems inefficient. Hmm. Okay, maybe let's just... Oh, okay. Oh, and yeah, okay, so if you ban recursion and overlapping, which I kind of do anyway. Okay, I'm good. I believe you. These are some beautiful... Okay, yeah, I I mean, this is just algebra. I don't think it helps me implement the algorithm. Honestly, it could be a pretty good homework in like the right kind of class. I guess like a formal languages class. Something. Okay. Okay, so I'm not trying to find. Oh, okay. This is kind of interesting. I mean, yeah, so basically, we can't basically NP complete other than if you don't have either recursion or overlapping. Oh, no, I. Okay, well, that's interesting. What is P? Oh, here's P. Is P just. What? Is it equal to P? Okay, I, I believe this. Alright, is there any discussion of the actual implementation of the algorithm? Okay, this is just also proves that this is NP complete. Okay, yeah, I am kind of skipping over a bunch of very interesting math, but it's 1020. Whoops. And I want to try and implement an actual. I am planning to write a line of code before I go to bed. Okay, so I guess then, um, yeah, I do remember skimming it and being like, oh, there's just math until section 5. How far did I go? Oh. Okay, wait, hang on. This is like the closest thing I've seen to an algorithm. I think I skimmed too much. Okay, so for any on a random access machine, what on a RAM? Okay, yeah, but I'm not that interested in optimality. I guess maybe I just go back to something like this. I mean, optimality is great, but it's very much a future me problem. All right, so if we start here, so if I take 3 characters to represent a pointer, or 3 bytes to represent a pointer, then it's only worth compressing if there's a repeated substring of at least length 4. The problem is, I mean, getting all of the substrings is so inefficient. Okay, so I guess that's what the rest of this was about. Uh, hmm. Right, I guess that is the difficult part. That's why me, when I assume that the non-trivial problem is probably trivial and I can implement it in a day. Um, yeah. Right, because so I can implement this. Like if you gave me all of these substrings of length greater than 5 that are repeated, then I'd be chilling. I'd be done. Like that'd be easy. And now I have a LeetCode problem. I mean, LeetCode doesn't exist. It's 1984, but I don't think that's a. I don't think there's a way of verifying that other than that's why there are a bunch of proofs about stuff being NP complete. What's like a reasonable thing to do? So I have a list of these characters. I have substrings. Right, it's the problem is constructing the dictionary. Decoding's actually like not that bad. I mean, I could just take blocks, but blocks might be like really bad. I mean, okay, so one thing that's like not unreasonable is if you pick like a size, like let's say I pick like 5 substrings, I can in linear time construct the frequency of each length 5 substring. And if there's any of them that repeat more than once, then I can replace it. So I guess that's not bad. Okay, that's an algorithm. That's an algorithm. So construct frequencies of length k substrings. You'd probably want to start k high and go down. Yeah. Starting from k max. I have to implement the fucking dictionary. I have to implement the fucking dictionary. Ah, shit. Do I? Yeah. Maybe I can do something like of moderate intelligence to not do that. But I mean, actually, okay. Secret insane hack. So, uh, okay. What I was gonna say is if you just take 8-byte strings or 8-byte, that's just a pointer. So you could just have an array that's sufficiently long, but I think that is probably too long. Let me do math real quick. So if I need, yeah, it's a 9 quintillion element, right? Nope, I do not have the RAM for this. I mean, I can implement a shitty dictionary. Just multiply and take the mod. Yeah, I can. Alright, so I construct the frequencies of a dictionary of length k substrings. K max down if any repeats replace with pointer. Is there are no dictionaries, right? I'm not. I mean, there is a dictionary. Like, okay, so I mean, there's a dictionary in here somewhere. Technically. But yeah, that seems really bad. So I mean I was just trying to look through the table of contents. Yeah. Okay, I mean, the other option is just to be slow, which I'm not, like, entirely opposed to. I mean, it's just O of n squared, you know, I'm not running this on big strings. I guess, okay, wait, wait. No, that, yeah, obviously, yeah, okay. No, that's, I mean, I don't have to store extra information, I think, but yeah, I'm gonna have to just do this O of n squared because I don't want to implement my own hash function right now. So I get the frequencies of length k substrings. I can store that in a list, like separately on the side. Or an array, I guess. So I construct the frequencies of length k substrings, starting from, like, let's say length 10 and going down. And then if there are ever any repeats, I just replace that with a pointer. And then I add that to the front. So I'll keep like a kind of running string going. That's my like string at the front. And then, yeah. And I can also, I assume I can limit my string at the front to be at most well, I guess then I don't even need the string at the front, right? Because if I already have to check the repeat thing anyway, just don't put the string at the front and just do the substitution. Okay, yeah, whatever. Okay, I guess I overthought this a bit. So instead, yeah, I just look through all, like, let's say length 10 substrings. And then if I see a repeat somewhere further down the line, I just replace it. Okay, this is not a very good. This is really not related to the paper. But I guess it's. Yeah. I want to write some code though. I would probably. Alright, so how do I actually do string stuff? Freak. It's been a while, huh? That's fine. Alright, let's start with the structures I need. I don't really need a structure for the pointer. Yeah, okay, so I have... So yeah, so... Yeah, so I can keep my original string and my new string. Yeah, so because... Oh, but what if the start moves? Maybe I do want the dictionary because the start can move, I think. Right, because if I do a replacement when I'm on like length 10, then I do a different replacement when I'm on like length 8, that's before the other string, then the start moves. Okay, yeah, so I guess I will do the EPM. I mean, I guess the thing, right, because it's really only an extra 3. Because it's just I have the substring that's repeated, and then I have 2 pointers as opposed to having the substring that's repeated and just 1 pointer. So it's not too bad if k is relatively high. I mean, okay, but what's this? What is this algorithm? Maybe I'll try to. I think I tried to find the Lombozov paper in my physical encyclopedia. I mean, but okay. What is this principle? Yeah, there, done. Okay, wait, what is delta? Is it defined at the very beginning? Did I just not read? Wait, so how are we defining all of this notation? But where is delta? A contraction. Okay, so it's just a shorter version of the string. Oh, Jesus. Neon, what am I doing? Alright. Yeah, so delta of S is just a contraction of S. Yeah, I kind of thought I would write code today, but I low-key was going to go to bed in like 20 minutes, so we will see. I mean, I'll be back on Thursday. maybe? Or Wednesday or something. Yeah, okay, so then this thing at the bottom that I was... Theorem, this is further than I wanted to go. Theorem 10. A compression by one of these algorithms of S is... Okay, so the compression, the optimal... So it's the optimality of how optimal this algorithm is. Okay. Okay, so this is the argument, this is the argument, this is the argument. So you can construct this string in linear time be the longest string Si test j such that I is less than k from n minus 1 to 1 by minus 1. Okay, so match I is a so match is an array of strings, so match I is a string. Okay, so it's you go backwards. Or no, you do go forwards. Ooh, okay. Oh, so it's dynamic programming. I should have paid attention to the code. Okay, this is the theorem. This is, okay. So this is the algorithm I'm supposed to implement. Ah, God. Dude, reading the paper explains the paper. Oh my God. Okay. Yeah, okay. The Wikipedia, I mean the encyclopedia physical encyclopedia, because 19 didn't lie to me. Okay. What does this say? Alright. Because this doesn't look like it uses any... Oh. I guess I have to define match K. So that I may not be able to do in linear time because I don't have a hash map. I have to, yeah, okay. So match is tricky. This is a non-trivial definition. Yeah, but okay. So short. Okay. All right. Let me at least define these data structures before, so I have written more than 0 lines of code, and then I come back to this. Oh, dude, this programming thing is hard. That's crazy. So I want to. So the longest string SI through SJ. This okay, this surprises me that this is possible in linear time, if I understand this correctly. So you go through all of the strings smaller than... You go through all of the strings before K, no? I guess you can... Oh, okay. So the idea is... Okay, so... Yeah, so I had the wrong indices. Okay, that's the problem. Okay, so that makes sense. I think, right? Because what you can do is, I mean, you just look for one character that matches, and then you check the second character, and then if you ever, I mean, that's a lot of checks. That's a lot of checks. You'd have to build like this tree, and it'd be kind of silly. I'm shocked this is Oben actually. I guess I have to read the other reference. Let me see if I can uh, legally, yeah, legally acquire that reference as well. I mean, okay, because the rest of this I believe is in linear time. I believe that, like morally, but I mean, obviously, step C and step D are, and step B is trivial. You just initialize an n+1 array. But this is a linear time. It's crazy. Like, yeah, this is such a classic algorithm thing. Oh, let me just the entire complexity of the algorithm. Let me just put that part in like one step, and then here's like B and D are completely trivial steps compared to A, dude. Why is like just make A like 3 steps, please? I'm sorry, I don't mean to be mean. I mean, I'm also like, not a great writer or a great programmer. So I mean, I'm not really in a good place to judge. But I mean, look, identifying bad writing and bad programming is much easier than than producing good writing and good programming. Why am I saying? Think about the algorithm, man. Okay, wait. Let's not think about the algorithm. I get the algorithm. How do I? How could I possibly do that? In, I mean, I'm like, how could I do this in like n² time? Oh, I guess computing all substrings is n², right? Because you just, yeah. Yeah, it can't be more than n², probably. It's like what you would do. So you go through I less than k. I've read my pseudocode so much like this Python language, which doesn't exist yet because it's 1984. So then you go through everything less than k. And then if si so you have, oh Jesus, I skip a line between each line of code that I write because I probably. Alright, so then you have your candidate, which is just an empty string, right? If there's, yeah, you have your candidate, which is just an empty string, and then, yeah, so then you go through if si is actually equal to sk, then Well, I'm just writing Python. I write Python for work, and I think I just wrote out the entire algorithm in Python. But like I didn't. I was intentionally like, oh, let me not look up like the an implementation of the algorithm because I don't want to just like do a translation thing. But I mean, I mean, I arrived at it. Like this is my own derivative. Yeah. I mean, it is what it is. Because I mean, the thing about translating into fourth is that the fourth is very different from a lot of other languages. So maybe the way you would do things is kind of different. But I guess I mean, like this is more like C, right? Like the difference that fourth has from Python here is not in the way that I'm doing the algorithm to solve the problem. It's just, oh, I need to manage my memory manually and among other things. But I mean, we'll see. I mean, also, if I want to continue programming in fourth, translating other things into fourth is like a useful. I mean, useful is a maybe a strong word, but whatever. I'm gonna write the Python. I'm gonna type the Python code in, and then I'll write the actual fourth data structures that I need for it, and then call it a night. Yeah, I mean, the step A is just very tricky. Like, this algorithm is like n cubed, dude. What are they doing for O of n? Jesus. Like, just to find match k is n squared. Yeah, I'm gonna need to read reference 23 probably because we cannot be vague posting this hard. Like, what? Like, bro. Which ones? I mean, okay, I get it. You're setting a reference. I mean, this is not. This is a different paper, obviously. I'm sorry. I'm complaining too much. I mean, this is. I'm complaining too much for 1984. You know. Like, but I mean, it's obviously like the whole the programmers back in the day were cracked or whatever. It's like okay, I mean they were, but also like, I mean they spent time writing the code. Like maybe this would have taken them a couple of hours as well, and that's okay as long as it takes me less time the next time. Yeah, okay. Oh, what the heck? I don't even know what buttons I pressed. Okay, so I've been meaning to do the send a PR to Tracer because this is a comment. Alright, yeah. MK, match K. How about... I can subtract K, but whatever, it may as well just... Oh, am I... Do I have one extra layer that I don't need? No, I don't. This needs to be here, I think. Yeah, because you check all of the substrate. Wow, this is bad. Yeah, I'm interested in how this O of n cubed that I've naively written becomes O of n. I mean, this finds... I mean, this finds the longest strings. Like, I mean... Like, it seems pretty obvious you get this down to O of n squared. Probably with some, like, smart caching thing, but... O of n... That just seems difficult. Right, and then... Yeah, okay. So... Well, I don't need the manual if I have the things I wrote before, which are great and awesome. Right. So... In this case... what structures do I actually need? Short, I guess. I mean, but can't I just... store a bunch of pointers in a list? Like... Oh, because you need to do this... Right. Okay, you need to store... You need to store these pointers. Wow, this is okay. This is a good algorithm. People should use this. Compressing data. Okay, that version of that bit didn't work. It's whatever, man. So I guess a short entry would consist of I don't need the length because it's okay. Yeah, this part I do think I can understand how to do in linear time. Okay, so they're just missing a space there. Okay, so I guess what I want to do this is like a flat, like one of those like tagged union things, right? Because either so like this is like the type of this is what? Hello? Comments? Is that not how I write comments? Right, so this is a so it's either a so type like pointer pointer. So it's a compressed pointer pointer cross a right? Am I? I'm actually. I need to go to bed. Yeah, I mean, okay, this combination of function, whatever. Yeah, okay, yeah, basically the problem is I really need to go to bed. But yeah, so we have a short entry in both cases, and then we just either have a, I mean, you know, we either have a character. Yeah, it's not even a character pointer, it's just a character. Or we have just a compressed pointer. I mean, char f0 not here. And so then we have a so just to be clear, qi wait, I swear qi oh. Okay, yeah. Yeah, because I don't know what type these are yet. Like, could be characters. But I mean, yeah, you want them to. I mean, I guess like what you can do is you can have them be ints and just make them as long as you need. But then you need to have a separator. Gosh, dang it. You could also just write the number and then argue that the number, like at the length number, the length number for sure, you can just write the number. Like if you just write the number down in the string, because like if you have a length like 20 string, like okay, it took 2 characters to represent 20, and then you could have done it in one, but like it doesn't matter. Okay. Yeah, I need to go to bed, unfortunately. Programming is hard. Reading papers is hard. Yeah, but I think I have a direction, so that's good. I don't know. Have a good day. Yeah.